This is my third video in my module on measures of central tendency, in which we're going to discuss how to find the median and interpret what it represents, okay? So let's start with what we mean by median. When you hear the word median, you should be thinking middle, okay? So when we talk about the median of a data set, we refer to the middle of the data set, okay? So it's important to note that when you find the median, 50% of the data should fall above the median, and 50 percent should fall also below the median, okay? So we refer to this as always the middle term. This is singular. There should be one term in the middle if the data has been put in order. So the important thing here is this. It has to be put in order, what we call a data array. When we say a data array, we refer to a data set that has been ordered, okay, from usually least to greatest. So we're just going to go ahead and find the median on these three and talk about, what it represents and how to interpret it. So example number 4 here, we say the number of rooms in 7 hotels in downtown Pittsburgh are these values here. We say find the median of the data array and tell what it represents. Well, since we need to put this in order first, we're going to go ahead and write our data set in order. We have 292 being the minimum, okay, almost said median. 292, next one up in line, looks like we have 300 here, 300. Next one is 401, followed by 411, so 401, 411. So those are out of the way here. We have next 595, 595, 618, and lastly 713. So here's our data set in order. One thing I do want to mention before we start is this. The number of data here, we said we had 7 hotels, so we say 7, and we of course count the number of data here. This is kind of important because when you consider the median, I wouldn't really cross these things off. I usually use my fingers to count in, but you just count in one side at a time, so 1 and 1, 1 and 1. 1 and 1. You'll notice we land here. I would actually recommend putting a box on this, and so we say this right here, 411, is our median. So we say median of this data set is equal to 411. There is no abbreviation for the median or special symbol we use for this, but we say 411, and this is rooms. Okay, so we can interpret this as saying, well, looking at all of these different hotels to compare in downtown Pittsburgh, half of the hotels have more than 411 rooms, and the other half of the hotels that we looked at had less than 411 rooms. And it's also considered like the middle of the data. Okay, so in the last video we actually did find the average as well. I just want to point one thing out here. Average is kind of also a measure of central tendency, but the most typical case. So if we were to sum these up, we say 292 plus 300 plus 401 plus 411 plus 595 plus 618 plus 713, we determine the sum of our data. So we'd say is 3330. So we say sum of all of our data is 3330. We had n is 7. So our sample mean here would be x bar would be 3330 divided by 7. Excuse me. So what we end up with is this. We say divide by 7. We'll round out to one extra place value. So 475.7. So approximately 475.7 rooms. You can see that these two values are relatively close to one another. Actually, they're not that far apart with respect to everybody else in the data set. So median is also a good measure of central tendency. You'll notice that 411 rooms was actually one of the original data, whereas the average was not one of the original data. Okay, so let's try this again. Find the median for the ages of 7 preschool children, if these are the ages. I don't know, I just kind of made up this data set. I'm not saying that they're typically 1-year-old in preschool, but if we put these in order, again, we say 1, 1, so those are gone out of our data set here. 1 and 1, we have a 2-year-old, 2. Next up, we have 2 3s, so we say 3 and 3. Sometimes easy, just count up how many you have of each, a 4 and a 5. If you had to just have me look at this data array, I'd say, well, it seems to me like 3. But if we go through and cross these out, we say 1 and 1, 1 and 1, cross off, put a box around it. So we say median. The median age here is 3 years old. And again, it just means that half of the other preschoolers are above this and half are below it. Okay. This last one here, number 6, it says the number of tornadoes that have occurred in the United States over an 8-year period are as follows. I want to find the median of this data set, tell what it represents. Interesting thing I want to point out is this. We have 1, 2, 3, 4, 5, 6, 7, 8 data. So what's going to happen when we count in from the outsides and have an even number of data, where n, in this case, is 8, which is even. Okay, you probably already know how this goes down here. We'll go ahead and put this in order. Seems to me we have 656, 684, 702. 764. And we also have, let's see, these are gone. We have 856, 856, Next up is, let's see, 1132, 1132, 1133, and 1303. So here are 8 data in order from smallest to largest. This is our array. When we count in this time, what you're going to see is we can count like 2 at a time in. 1, 2, 1, 2. Cross off these ones here, but you're going to land on 2 numbers. And I like this box method because what we're going to do here is, and I don't often write this, but we're going to find the average of these 2 numbers. This is an entire section on central tendency which focuses on different measures of average. But in this case, we'd say, okay, 764, I'll pull this down here, 764 plus 856 equals divided by 2. So we get a median of 810, we can say 810 tornadoes, okay? So this would be a fair number of tornadoes to say half of the years were above 810 tornadoes, the other half are below 810 tornadoes. So this is our median value. But I do want to point this out. The median, in some instances, doesn't have to be one of the original data. 810 was not in our original data set here. So this is going to happen every time we have an even number of data. You have to average the middle 2 data. Cheers.